This lesson is on estimating derivatives. And in the last lesson, you learned how to find the general derivative of a function, the expression of the derivative of a function, using the definition of a derivative using limits. And that works really well to find the general limit. It just takes us a lot of work. Sometimes we have functions that won't fit into that formula quite so easily, or won't simplify so easily to cancel out the h on the bottom so that we don't have 0 over 0. And example number 1 would be an example of that, where I have sine of square root of x. That would be a whole big pain to try to simplify that. So instead of actually finding the expression for the derivative, what I'm going to do instead is just find the derivative at a certain point. And for that, we are going to be using your calculator. So this video is going to show you on the Casio FX 9860G. If you have one that's slightly different, the steps are going to be mostly the same. So the idea here is that instead of having to find the general derivative, we're just going to find the derivative at a specific point. So we have f of x is sine of the square root of x, and we want to find f prime of 2, the derivative of the function or the slope of the tangent line at the point x equals 2. So in order to do that on your calculator, I'm going to go to this OPTN button. This is options, and will open up for me this option calc. This is short for calculus. So I choose calc, which is F4, and right here you should recognize this d by dx as one of the forms of our derivative notation, just like this f prime is something else that indicates it's the derivative of f at a certain point. So I'm going to choose that option, d by dx, and then I'm going to type in my function. So I have the sine of the square root of x, and I want to find that derivative at the point x equals 2. So I'm going to use this is a comma, so click the comma button, and then just plug in 2, close your parentheses, and that tells it I want the derivative of this function with respect to x at x equals 2. Hit enter, and it's as easy as that. There is the slope of your tangent line, or there's your derivative at x equals 2. So f prime of 2 is 0.055. Round or truncate to 3 decimals, and that's it. So not too bad. If you start out at the main screen again, that was the sequence was OPTN, the option button, then F4, which is calc, and then d by dx will get me the derivative with respect to x. So if I try number 2, then I've got f of x as being the natural log of 1 over 5 minus x, and I want to find the derivative at x equals 1.3. So I'm going to again type in d by dx, natural log, parentheses, 1 over, I'm going to put parentheses around my denominator, 5 minus x, close that, close the natural log parentheses, comma, 1.3 is where I want it evaluated, close that parentheses, hit enter, and it's as simple as that. So the f prime of 1.3, or the derivative of the function at the point 1.3 is 0.270. Round or truncate to 3 decimals. And that comes in handy for us, again, if we want to do something like write the equation of the line tangent to a certain function at a certain point. So if you remember how that works, this was y minus f of a was f prime of a x minus a. So in this case, my a value is going to be 1, so I need to find f of 1 by plugging in 1 into my original function. So square root of 1 over 1 cubed plus 1. So f of 1 is square root of 1 over 1 cubed plus 1 is 2, square root of a half. My calculator can evaluate that for me if I want, but that turns out to be 1 over root 2 or root 2 over 2. And I could give this as a decimal, and probably I should do that because my slope is going to be as a decimal. So that is equal to 0.707. So that's my f of a, f of 1. F prime of 1 is what I'm going to find on my calculator. So again, d by dx, type in my function, so square root, I'm going to need a whole bunch of parentheses for this, 1 over parentheses, not 1 over, sorry, x over parentheses, x to the power of 3 plus 1, close that parentheses, close the square root parentheses, evaluate that at the value of x equals 1. Close those parentheses, gives me a slope of negative 0.17. I'm going to round, you could truncate as well, 176 or 177. That's going to go in here, and then x minus a is just going to be x minus 1. So I have all the information now, I can put it in there. So y minus 0.707 equals negative 0.177 times x minus 1. And there you have it. After all that work is the equation of my tangent line. So again, calculator, helpful to find the slope of your tangent line at a given point. Useful? I think so. Let's take a look at a few more examples that have to do with estimating derivatives. This time we're going to use estimating derivatives from a table, so we don't technically need our calculator for this one, so maybe I'll put it away. So, estimating derivatives from tables. In order for this to be possible, the function must be what we call differentiable. And you're going to see a formal definition of this in the next lesson. We're actually going to connect continuity with differentiability. But really, all you need to know for differentiable means the derivative exists. And in order for the derivative to exist, our graph has to be continuous, so no breaks, and it has to be smooth, so no funky corners or anything weird like that. So continuous and smooth, something just like that, continuous and smooth on the interval where we want to take the derivative. So in this lesson, you don't really have to worry about that because all the examples that you're going to see will be differentiable. In the next lesson, you'll see a bit more. So it says, we've got this table here, x is in hours, f of x is miles, and we want to use the table to estimate f prime of 3. Now 3 isn't technically on my table directly. So f prime of 3 would fit in right between 2 and 4. So in order to find the estimate, remember this is an estimate of the derivative, it's not the exact one, we're going to find the average rate of change. The average average rate of change from the points on either side, or this is just the slope between the 2 points on either side of where my actual value would be. So I'm going to look at the 0.23 and the 0.410. So average rate of change would be on the top, f of 4 minus f of 2 over 4 minus 2, or remember this is y2 minus y1 over x2 minus x1. So f of 4 is 10, f of 2 is 3, and 4 minus 2 is just 2. So this is going to be 7 over 2, or you could also write that as 3.5, and now we just got to add on the units. So my f values were in miles, and my x values were in hours, so this is miles per hour. And again, totally fine if you want to write that in a decimal, 3.5 instead of 7 over 2. Just for me, easier, 7 over 2 came out right away. So again, if you want to estimate the derivative, then find the average rate of change or the slope between the points on either side of where my actual value would be. So this isn't the exact derivative, but it's an estimate. One more example before I set you loose. I have here x in seconds, w of x is in gallons per second, and I want to use the table to estimate w prime of 100. So maybe you want to pause your video now and do this one on your own and then see how it goes when you come back. Okay, so 100 is going to be right between 80 and 200. This is where my 100 would fit in. So I'm going to use 80 and 120. F of 120 minus f of 80 over 120 minus 80. And f of 120 is 500. F of 80 is 700. 120 minus 80 is 40. So this is going to be negative 200 over 40. If you do that division, this is negative 5. So in terms of units, I'm looking at the top is gallons per second. So gallons per second. And the bottom is also seconds. So this could be gallons per second because there's already this per second. I'm going to need it twice. I can't just have gallons per second because my original was gallons per second. So gallons per second, or you may recognize this from physics, gallons per second squared. Usually write it as gallons per second squared, but if you wrote gallons per second, also fine. There you have it. That's it for this lesson. Good luck on your homework and your mastery check.